Hello students, welcome to the third video of Science Class 7, Chapter 13, Motion and Time. In the previous video of this chapter, we have discussed about the measurement of time, and in today's video, we are going to understand graph of motion. So, let's get started. Let us understand what is the relation of graphs and motion. The graphs are used to organize information, and graphs can be made up of bars, lines, pictures or pieces of a pie, and they help us to see and understand the information. And students, you must have read about graphs in detail in your math subject. Graphs can be in the form of bar graph, pie chart or line graph. So let us understand how these graphs help us to understand about motion. First, let us understand the bar graph. The graph shown on the right side of your screen is a bar graph, and a bar graph uses column or bars to show the information. For example, the adjacent bar graph shows how most students in a city go to school, and by studying the graph, it is clear that the most of the students use school transport to go to school. And second type of chart is pie chart. Students, a pie chart is shown on the right side of your screen. It shows the amount of different gases in air. It is divided into fractions that look like pieces of pie. Pie charts are the best to use when one tries to compare parts of a whole. They do not show changes over time. It is clear from the given pie chart that air has maximum percentage of nitrogen, and the data points in a pie chart are displayed as a percentage of the whole pie. And the third type of graph is line graph. The graph on the right of your screen shows the temperature recorded every 3 hours during a day. It is a line graph, and a line graph shows points plotted on a graph. These points are then connected to form a line. Conclusions are drawn after studying the graph. Line graphs are useful for depicting the changes in a value over a period of time. Hence, for instance, the maximum temperature of the day is observed from 12 to 3 p.m. And students, now let us understand about the distance time graph. Graph of motion are an important tool to show the relation between distance and time. And students, let us learn to use the distance time graph to describe the motion of a different objects, considering the following example. Here, example 1. Kavya is helping a friend who is running for a track event in an athletic meet. Her friend wants to know how fast or slow she is running during a section of the race. Kavya marks the track after every 50 meters and measures the time at each position during a practice race, and the data collected by Kavya is shown in the table. And here the data collected by the Kavya is shown in the distance time graph. Here the distance is marked on the vertical or y-axis and time is marked on the horizontal or x-axis. And the graph drawn here shows the distance covered in the different time intervals. And students, by observing different distance time graphs, we can understand that for something traveling with uniform motion, the speed does not change or remains constant. Thus, a straight line graph indicates a constant speed. However, if the speed of the object keeps changing, the graph is not a straight line. And students, now let us understand the distance time graph of a stationary object. Let us consider another case when the object is stationary. Suppose after walking 4 minutes, Shikhar decides to stop at the book shop for 4 minutes. After that, he continues at the same speed as before until he reaches school. The graph of his journey in this case is shown in the graph on your screen. Let us try and understand how to recognize Shikhar's halt on a distance time graph. When Shikhar stopped after 4 minutes, he had already travelled a distance of 200 meters. And for the next 4 minutes he did not move. So, although 8 minutes had passed since the beginning of his trip, he had still only gone 200 meters. That is why the next point on the graph will be plotted at 8 minutes and 200 meters. Locate this point on the graph. The straight line joining these two points is parallel to the x-axis. Whenever anything stops at one place, although time continues to increase, the distance covered does not change. That is why, as we have just seen, the line on the distance time graph for this halt is a straight line parallel to the x-axis. And students, now let's revise what we have learned today. Question 1. The data points in a pie chart are displayed as a dash of the whole pie. A. Fraction. B. Percentage. C. Multiple. D. None of these. And the right answer is B. Percentage. Question 2. The distance time graph for a stationary object is dash to the x-axis. A. Vertical. B. Parallel. C. Perpendicular. D. All of these. And the right answer is B. Parallel. Question 3. A straight line graph indicates A dash, A constant speed, B non-constant speed, C acceleration, D none of these. And the right answer is A constant speed. Practice makes perfect. Students, it's time to practice. And your practice homework are on your screens. See you soon with a video of next chapter. Till then, take care and thank you for watching.